Now, probably to your favorite topic, subnetting. Well, let's do a quick review of subnetting with IPv4. In IPv4, we had a broadcast address and we had a network address. And I have an example network here, 172.23.5.0/24. The slash notation means we have 24 bits of network and we have the remaining 8 bits for hosts. So the network mask can also be written 255, 255, 255, and 0. And as you know, the network address is the .0 and the broadcast address is the .255, at least in a /24. Let's do a quick example. Your IP address is 172.23.5.1. It's 32-bit address and it's in decimal notation. I also wrote down the binary notation. So the network mask is 255, 255, 255, 0. It's 24 bits and can also be written in /24. I also showed you the binary notation of the subnet mask, which is 24 bits of 1 and 8 bits of 0. These 8 bits are the host part and the preceding 24 bits are the network part. The network address is the first 24 bits of the whole address. Look on top, look at the notation of the whole IP address, and we only look at this first 24 bits. This is the network address, and this results to 172.23.5.0. And what is the broadcast address? I told you, it's all ones, but sure, only the host part, not the network part. So in this case, broadcast address is 172.23.5.255. How many addresses do you have? Well, you have 0 up until all ones. It's 256 addresses. On the left, there is a little chart which maybe help you. So the bit on the right is 1, the next bit is 2, bit number 3 from the right is 4, then it's 8, up until 128. And if all bits are set to 1, we have 256. The next network after 172.23.5.1 is the network mask added by 1. So it is 172.23.6.0. Let's have a look at another example. You have another address from another space. It's 10.1.2.52. This is also 32 bits, and I told you the binary notation. This time the subnet mask is a bit harder. It's a /27. And /27 means we have 27 bits set to 1, and the remaining bits are for hosts. So, what is the network address? Just look at the whole address in binary notation above and use the network mask, and you will find out, oh, the network address is 10.1.2.32. Why? I marked it in bold. What is the broadcast address? Well, broadcast address is the network address and all the host bits set to 1, which is 10.1.2.63. It's pretty easy, right? You can always use the chart on the left. The number of addresses this time is smaller. We have less zeros and we have less ones. So the maximum number is 32 if you count everything 0 to everything 1. The next network in this case is 10.1.2.64. Most people probably do this in their head, but with IPv6 it's different and it's a bit important that you understand, at least if you want to do IPv6 subnetting. Let's have a quick overview. This is the chart again, which tells you all the prefix lengths and the corresponding subnet mask and the bits of network and how many IP addresses you have. If you have a /32, you only have one address. If you have a /8, you have about 16 million addresses. So, what's different? Let's have a look at subnetting IPv6. I can tell you, everything is easier. Don't worry. This is the subnetting chart. It looks hard, but it's not. As I told you before, in IPv6 we have 128 bits. You already know how to convert an address from the long form to the short form. You know what one nibble is. It's one hexadecimal digit and it equals 4 bits. So 2001 in hexadecimal means 0010 and a lot of zeros, and 1 at the end. You can also calculate using this chart on the left. As you can see, this chart only has 4 boxes and not 8 anymore, because we only have to care about one nibble, so only 4 bits instead of 8 bits, even easier. In IPv6, we do not have any reserved network address. The first address of the network can be used for host addressing. We also have no broadcast address, because you remember there is no broadcast anymore. And the prefix length is always specified in slash notation, so there is no network mask like in IPv4 anymore. Let's have a look at an example. On top, you will see the long form. You already know how to shorten that. You can leave out all the leading zeros, and you can replace any number of zeros, only once, with a double colon per address. The second is the shortened form. In this case, the prefix length is a /64. The red part is the network, and the blue part is the host part. This network starts with, the network and all zeros, and the end is the network address and all ones in binary or F in hexadecimal. You can again use the chart on the left, which you can see is easier, because before we had 8 bits and now we only have 4. In this case, the network is a /48 and the target network size is a /64. I will tell you about the different sizes later. What is your first network and what is your second network? Well, the first one is the network address of the large one. So in whole, it is the 0 network, 0, 0, 0, 0. The second network is added by 1, 0, 0, 0, 1 in the fourth part. And the last network is FF, because in hexadecimal, F is the largest number. And in total, we have 65,536 networks available in this /48 if you divide everything into /64s.